Good afternoon. I'm NASA's Megan Cruz, and you are watching a press briefing following today's launch attempt of NASA's Boeing Crew Flight Test with NASA astronauts Butch Wilmore and Suni Williams on a United Launch Alliance Atlas V rocket and Boeing Starliner spacecraft. Now, NASA, Boeing, and ULA were less than 4 minutes away from liftoff at 12:25 p.m. Eastern Time today, when teams had to forego the launch because of an automatic hold on the ground launch sequencer. So to talk more about that and what happens and what's next for this mission, we have here for you Steve Stich, Manager, NASA Commercial Crew Program. We also have Mark Nappi, Vice President and Program Manager, Commercial Crew Program, Boeing. And finally, Tory Bruno, President and CEO, United Launch Alliance. Now, you know the drill. Each will say a few words, and then we'll open up the floor and phone lines for questions. So, Steve, why don't you go ahead?
Yeah, thanks, Megan, and thanks to all of you for being here and your interest in our Crew Flight Test. We got really close today, and I would say the team did a phenomenal job, the joint NASA, Boeing, United Launch Alliance team working through the countdown today. You know, the day started off, a busy day for NASA at the International Space Station. We had a progress docking, 88 progress this morning at 6:43 a.m. Eastern Time, so the progress docked nominally, and the station's doing well. At the same time as progress, of course, it's always busy. We got into the launch countdown today. Turned out the weather was a beautiful day to go launch. You know, we were worried about the onshore winds, and those held within limits. They were right at about 14 knots, and so those would have been acceptable for launch today. We had a great chance to go look at the helium leak in the service module, what we call the P2D2 flange in the manifold 3 in the port doghouse, manifold 2 in the port doghouse. And we looked at that leak today, and that leak looked like it was about half of what we saw before. So, you know, we talked about it being on the order of 80 psi per minute in that manifold. Today, it looked like it was around 40 psi per minute. So that leak, you know, we think maybe the seal moved a little bit, or the defect got sealed up a little bit. So that was good, and that would have been no issue for launch. So we went through our whole troubleshooting procedure, and that would have been just fine. I would say the launch vehicle did great. The Atlas and Centaur did great. The self-regulating valve that we talked about, worried about a little bit going into the countdown, performed well. We didn't see any resonance at all, so that went really well. We did have a couple of items that we worked in the countdown, and Tori will talk more about those. We stopped in the topping phase on the Centaur. We had a little bit of a failure on the ground side, I would say, in the command and control system for those valves that are on the ground. And the ULA team did a magnificent job working through that. We got into a good configuration there. And then, you know, right before we got into the final phase of the count, went off of ground power onto spacecraft power. We saw a little bit of a swap in the cabin fan, a little voltage sag. The ground team did a great job of troubleshooting that. We verified both fans were good, and we got those in a good config for launch. And then, of course, we got inside 4 minutes, and then we had a problem with the ground launch sequencer, and I know Tori will talk more about that. I know it's a little disappointing. We were all excited, and Butch and Suni were excited to go fly. This is kind of the way spaceflight is. This is my 37th year at NASA today, and been doing this human spaceflight for, thank you, a long time. And every time you go to the pad for a crewed flight, or really any flight, you've got a chance of scrubbing. So the team took the right steps. We weren't ready to go today, and Tori will talk more about that, and I'll turn it over to Mark Nappi now.
All right. Well, thanks everybody for coming out this afternoon. The spacecraft and the launch team really did a great job today. The spacecraft performed extremely well. Steve talked about the helium system. It turned out that when the system was brought up, the team looked at the information really quickly, got us the leak rates, and ended up being no action required. So that's what we expected. On the cabin, on the suit fans, as we went from ground power to spacecraft power, a slight increase in voltage. We have a fault detection system that picked that up. It did what it was supposed to do, and it turned the fans off. Our team reacted just like they're supposed to very quickly, and they cycled them back on again. So that worked just as we would like it to. For tomorrow, or whenever we try our next launch attempt, we'll have that figured out, and we'll either let the same thing happen and see if there's the same voltage, or we'll just go in and turn them off and turn them back on again. So the team's working that, and we're fine for the next attempt. We're in a 24-hour scrub turnaround. We're trying to preserve that opportunity, and we'll stand by while ULA does their troubleshooting, and then we'll take either that opportunity or the next one to come. Like Steve said, this is the business that we're in. Everything's got to work perfectly, like we've talked before. Today we got really close. It didn't work for us. The team's very professional. They're in their 24-hour scrub work turnaround right now, and when we're ready to go, they'll be ready to go. So I'll turn it over to Tory.
Thanks, Mark. Well, as Steve said, the vehicle performed beautifully, and we really had nothing to talk about on the vehicle itself. I also felt that the NASA, ULA, Boeing teams work really well together, which is important as well during a count. We had 2 events on the ground system, specifically that system that is housed inside the shelter at the base of the pad. So when you see the rocket roll out to the pad and the P-vans continue going into a building, it's in that building that we're talking about. And these events are associated with the controllers, the large computers that are housed in that building. There's 3 of them. They're the same, they're redundant, so it's triple redundant. The first event that we talked about had to do with the ground side topping valves. That one of those 3 racks was not commanding them to be open when we wanted them to be open. It is triple redundant, so we never had an issue with crew safety or with safety to the vehicle, but we worked through it and we switched the primary control to a different of the 3 racks, which is acceptable for that system. And so topping continued, and we never really deviated from that. As we get down to terminal count, then we do a health check of other systems, and one of the key systems there is a different card in the 3 racks that controls what is referred to as the launch sequencer. And that's a computer that controls things like retracting umbilicals and the pyro vents that release the bolts at the base of the rocket, so that when ignition happens, the rocket is free to fly away and do its job. And for that system, we do require all 3 systems to be running, triple redundancy. And to assure that, each of those 3 big racks, those 3 big computers, do a health check. And they monitor to see that those cards came up when they were commanded to come up and begin doing their job. 2 came up normally, the 3rd one came up, but it was slow to come up. And that tripped a red line that created an automatic hold. Because although the health system did not note that it came up anomalously, it took longer, and so something is not correct. This is an instantaneous launch window for us because of the unique crew safety trajectory we fly. We're not able to use our famous RAN steering like we do when we take cargo to the space station. And so as a result of that late in the count, that ended up scrubbing the mission. What will happen next is to gain physical access to that computer and determine why that occurred. We can't get in there until we're done defueling the rocket, which is followed by making sure there's no stray hydrogen inside that building so that it's safe for people to be there. Then we'll go in and we'll troubleshoot it. So we are probably not less than, say, 3 or 4 hours from understanding what occurred. And if it's as simple as replacing a card, we have spares for everything. And we would do that. We would test it, which is required, and then be in a position to support a recycle for tomorrow. If it's more involved than that, or it just takes longer to get through all of that, then we would move to the backup day on the 5th. And as you know, we're set up for a backup on the range on the 6th as well. Weather for all 3 of those days look good. And so we'll know more, much later this evening.
Thanks, all 3 of you. Okay, so for those in the room, raise your hand, wait for a microphone to get to you, and then for those on the phone, you can get into the question queue by pressing *1. So Marsha, go ahead over here.
Marcia Dunn, Associated Press for Tory. It sounds like a hardware issue. Is that your best guess, or what's your leading suspects at this point with this third computer?
Yeah, the leading suspect would be either a hardware problem or a problem with the network communication between these, between the three computers and the system that interrogates them. But we won't really know until we get physical access and can troubleshoot that one rack that has this one card that came up slow.
Okay, over here, right behind Marcia.
Hey, thanks. Chris Davenport with the Washington Post. Tory, when you're talking about a card, I wonder if you get a little bit more information about what you're talking about in terms of that, if that's what that entails. Thanks.
Absolutely. So you should imagine a large rack that is a big computer where the functions of the computer as a controller, we call it a RIC, are broken up separately into individual cards or printed wire circuit boards with their logic devices. So they're all standalone, but together it's an integrated controller, which is what RIC is, integrated controller. And we do that to make it easier to troubleshoot them and to swap out parts so that you can replace just one element of it without having to replace the whole thing. It also helps in isolating which part of that control system is having a problem, if indeed it does. So you would imagine sort of three big racks side by side in this building with like 15 to 20 cards in them. I don't remember the exact count. And what we're going to do tonight is we're going to go in there and troubleshoot the cards. We'll likely have to remove several to evaluate everything, including the chassis, the power supplies, the network communication between them, and isolate exactly why that happened.
Okay, we have one in the third row there. Yes.
Mark Ratterman with Talking Space. A question for Tory. How many people will be hands-on looking at the equipment directly in front of it? How big is that team?
How many people will be in the shelter doing the physical troubleshooting tonight? I don't know off the top of my head. Probably half a dozen folks will be in there. There'll also be lots of people supporting them, both here and back in Denver. The design team will stay on and work through the evening with them to get to the bottom of it.
Okay, I see three in the room right now, then we'll go to the phones. Go ahead.
Jeff Faust, Space News. For Tory, is there a connection between the issue you saw with the topping valves earlier and then the issue then when you came out of the T-4 hold? Is it the same computer, the same card, something like that?
Sure, Jeff. It's different cards, but the same rack, or the same RIC, if you will, large computer. So they might not be related because remember I said the cards are separated by function. But on the other hand, if it's something common in the comm system, or the network within that rack, or its power supply, then it could be. I won't know until we get hands onto it tonight and then troubleshoot it.
The woman right here. Sorry, I should give you a break. You've been chasing people around.
Hi. Lauren Grush with Bloomberg. For Tory, you mentioned if it was a more involved scenario, can you give us an example of what would be more involved other than just replacing a card that would push it back a few more days?
Yeah, they're an integrated rack of functional cards that have to communicate with one another and then communicate with the system. They're in a network, if you will. And so if there is an issue with that integration through the network, that would be more involved. If there were a problem with the power supply, it could be more involved, although we have spare parts for that too. We won't really know until we're in there tonight, hands-on.
Okay, we'll take Tom over here, and then we'll go to the phones and back into the room.
Hi, good afternoon. Tom Costello with NBC News. Thank you for this briefing. It sounds like you're more leaning towards hardware versus a software problem. Is that accurate? And second of all, if in fact you want, it's going to take 3 to 4 hours at this point, you said, before you gain access, and then you've got to try to figure out where the problem is within the rack, which card. Is it reasonable to think that you could still potentially move towards a noon launch tomorrow after you've completely, taken all the fuel off, then try to load again tomorrow? Or might you want more time to just absolutely be sure that you've nailed it all down?
Well, this is a crew mission, so we're going to be absolutely sure, period. Is it possible to be absolutely sure for tomorrow? Yes. If it's a simple matter as we examine the card that is the launch sequencer and find that it had a piece of hardware, a component, for example, that reached the end of its life, then it would be a simple matter of replacing it, and we would be able to support it. We have to put our crew back on console by 12:30 or so this evening. So that's sort of how long we have to do that. And again, if we can isolate it right away, we have spare parts here, we'd replace it and we go. Again, if it's more involved, then we would not be able to go.
At what time do you expect to make the call? Sorry, do you have an idea of when you make the call?
It'll be late tonight. It depends on what it is. If it's very obvious and it doesn't involve the systems that are utilized between 12:30 and, say, for example, heading into terminal count, we'd have more time. Obviously, we can't have people there when we're fueling the rocket.
Thank you. And if we're moving off the launch date, we'll get the word out tonight to you guys. I know you guys would like to know, and everybody would like to know. So if we're moving the launch date, we'll try to get word out tonight.
Absolutely. All right, let's go to the phones as promised. So we have Bill Harwood, CBS News.
Hey, thanks very much. This is also for Tory. We've been told that obviously you guys have to replace some batteries if you don't make it off the ground by, I guess, Thursday. Are those flight termination batteries? And I was just wondering, where are they located? Do you have to roll back to the VIF to do that if you have to? And how long would that add to the processing flow if you have to, in fact, change out the batteries before if you don't get off between now and then and you have to change out those batteries? Thanks.
Yeah, sure, Bill. So we're good through the backup day on the 6th. Beyond that, we have to evaluate it. And if we do have to change batteries, we will roll back. And it's about a 10-day cycle to go do that.
Okay, back here in the room. Over here.
Hi, Ken Kramer, Spaceflight Now. For Tory, what is the history of these cards and them having faults in them and having to be replaced over the course of the Atlas program?
Yeah, they've actually been very, very reliable. It's not unheard of to replace a card. You could imagine that all of these cards, that entire rack, all 3 redundant racks, were tested as part of the sequence leading up to the launch. They were all good. They all function nominally. They've all been used before.
So they've never failed?
No, I didn't say that. We've had card failures in the past. I don't personally recall whether this specific card has failed, but they're pretty reliable. We've been flying them a long time. We haven't had very many failures. I don't know that it's a card failure. Once again, I don't know what it is until we get people in there tonight and are able to examine it.
Thank you.
Let's go back to the phones. Micah Maidenberg, Wall Street Journal.
Thanks so much. I suppose it's for everybody. Could you just say a little bit more about, what it was like for the teams getting so close and then having it go the other way today? Thanks.
I can start off, and then we'll let Mark and Tory add. I mean, I think every countdown that I've been a part of, and many in my career, is a little different. I mean, this one, there's always things that have to get resolved in the count, and today it was certainly one of those kind of countdowns where the ULA team did a great job. When we couldn't get into stable replenish, when we had the failure, they did a great job working through that and getting to that point. It's always exciting to get the crew in the vehicle and watch that happen, and watch Sonny and Butch get on board, and then getting the hatch closed, and then the pressure checks, and then you get into the final phase of the count. And for me, I've been there too many times where you get a little excited. I think everybody's excited. Everybody wants to see the flight go, and then it doesn't happen. But then what really kicks in, and what I saw over in the control room and listen to the loops in Houston, is that everybody's very professional and they're used to it. The ULA team moved right into what do they need to do to safe the vehicle and put the vehicle in a good config. Mark's team, the Starliner team, getting the abort switch off and making sure that we had that in a good config for the crew. making sure the vehicle was safe, going through all those steps. And so there's disappointment. It's human to be a little disappointed, but then, you watch the team kind of get into action, safe the vehicle, and then you listen to the loops, and they're talking about what potential the potential cause could be, and that's what Tory's team is doing right now, is going to go and look at the rack and get their hands on the system and look at the data from today. Is there anything they can glean from the data? So it's disappointing. Everybody's a little disappointed, but you kind of roll your sleeves up and get right back to work, and I'll see what Mark has to add.
I would agree with Steve. I'd kind of use the analogy of sports. When you're playing a game and you get a bad call, you're a little irritated at first or a little frustrated at first, but you immediately focus on the next pitch. And that's what our teams do. They're focused on the next pitch. As soon as we went into the launch scrub, the launch turnaround, I looked out into the control room, and everybody had their heads down, working the procedures to get ready for another attempt tomorrow. The technical guys were looking at all the things, all the data that they had so far, and they're scanning the data to make sure that nothing else was out there for us to go work. So the team's professional. They just work to the next play. Tory?
Yeah, I mean, you guys have said it. The disappointment lasts for about 3 seconds, and we've been at this a long time, and then you just immediately get busy and do your job. And we'll be back.
Joey? And then we'll bounce back to the phones. We have a couple on the phones as well.
Thanks. Quick one for Tory. Is it, just so I'm clear, is it accurate to call the 3 cards separate computers, or is it all part of a single computer?
3 big computers. Each one has several cards in it. And the reason it has several cards is because we separate the functions that you would observe being done through the count. So there was a card that controlled topping valves and other systems similar to that. This card controlled the launch sequence, which is removing all the things that are trying to hold the rocket on the ground before the rocket ignites. And this was that card within this big computer that had all those functions separated into different cards. There's 3 of those computers. They're redundant. Some of those systems majority vote. Some of them just require 1 to work. This one requires all 3 to work before entering terminal count, so that we are guaranteed statistically of having not less than 1 of them properly functioning at the moment of ignition.
For Steve, real quick, if it launches tomorrow, what docking time would that be on Monday?
Yeah. Of course, tomorrow, the launch time, if we go tomorrow and we've got to get through the troubleshooting, would be Sunday, June 2nd, 12:03 Eastern. And it's about a 24-hour rendezvous. So the rendezvous is Monday, June 3rd at about 1:05 Eastern or so.
Okay. Back to the phones. As promised, Stephen Clark, Ars Technica.
Thank you, Stephen Clark, Ars Technica. Just a question for Tory. I know you guys did not do a web rehearsal for this particular launch. If you had done a rehearsal, was there a chance this rack card issue could have been discovered as you came into the final moments of the accounts?
Possible, but unlikely. This system was tested during the run-up to this launch, and it passed those tests and functioned completely nominally. So it chose not to do that today. If there had been a WDR, I don't know whether it would have chosen to work that day or not.
And I would just say from my shuttle experience, every now and then we would have some failure at some system at the pad. The pad, we always think about Starliner being super complicated, and it is a very complicated spacecraft, wonderful spacecraft. The launch vehicle, both the booster and the Centaur are complicated, but the ground systems are equally complicated. I think sometimes we forget that, right? They all have to work together to launch, and I would say in shuttle, many times we would have a ground system failure that would cause a scrub, and that's what we had today. So.
Okay, back here in the room. If we can get a microphone to. Thank you.
Sawyer Rosenstein, NSF. After the topping off change that was done, it sounded like there was a release of 1,000 psi of helium. I was wondering if you can kind of talk about what happened and if you know the cause of that particular release.
Sure. So part of the sequence of moving that functionality to the other 2 cards and not using that first card in the rack did also vent the helium bottles, which we then had to recharge. It's a routine operation. I will say the only thing painful about that is the price of helium went up almost 10 times over the last 2 years, so we wince whenever we vent helium. But apart from that, it was a routine thing, and we simply recharged the bottles.
All right, back to the phones. Irene Klotz, Aviation Week.
Thanks, Megan. Tory, would the 3 controllers be required if this was not a crewed launch? And in general, how much tighter would you say the required launch commit requirements are for flying Atlas V with crew versus like your national security payloads?
Yes, Irene, we work very hard to have high mission reliability on every mission because they're all critical. The difference between this and a satellite mission that didn't have people on it, a satellite still requires all 3 redundancy to enter terminal count. However, we would have 2 things would have been different. One, we almost never have an instantaneous launch window when we are not launching people. This is a very unique and special trajectory that protects the safety of the crew by allowing them to have a free Earth surface routine all the way through Atlas's powered flight. And we're not able to do the things that create these big launch windows that we're more known for. So we would have had more time to look at the event. And during that time, knowing that there was no crew present, we may have arrived at a conclusion that it was worth proceeding with dual redundancy versus triple. It depends on what we were able to assess during that time. I don't know because that's not this circumstance. But with crew present, that was an unacceptable condition. And we were not going to make that decision in a few seconds, which is really all we had.
Okay, in the front row here.
Thank you. Faith Abube with ABC News, and this is to all of you. Considering this mission is now years behind schedule and with all the setbacks it's had, what do you tell anyone out there who's losing faith in this mission?
Yeah, I'll start, and then we'll see if Mark has anything to add. We are really excited about bringing Starliner on board the Commercial Crew Program and the International Space Station Program. We really would like to have and need 2 redundant space transportation systems. And, it's really important to us to have that. And, you could see today how close we are. We are really close to having this capability ready to go launch. We were 3 minutes and 56 seconds away from that with a Starliner spacecraft that was ready to go and an Atlas launch vehicle and Centaur upper stage that was ready to go. So the vehicles were ready. We just happened to have, an unlucky ground card problem. So we're really close to being ready to fly this mission and then go through our certification. And we're excited to go embark upon that, and we'll fly when we're ready, and it should be soon. So.
All right, on the phone, David Curley, Full Throttle.
Question for Tory. Have you ever had this happen before? You've had a lot of launches of this rocket. And if not, why do you think it is this one potential computer? Did you actually see signs that it was booting up slowly or responding slowly?
No, we didn't see any anomalous behavior with this card. The first indication of this event, again, was at the sequence just prior to T0, or I should say to terminal count T-4 that allows us to enter that, is powering up. As I said, 2 came up nominally right away. The third one was about 6 seconds slow. That it came up and it was functioning, but that in itself was an indication that something wasn't correct, and that's why the automated system tripped on that. We have seen card failures in the past. I don't recall if we've seen this one fail in the past. They are relatively rare. This is the 100th flight of Atlas, so we haven't had more than a handful of these over the years. So it's not a common occurrence, but neither is it something that's unheard of.
Okay, back here in the room. We'll go here. You've been raising your hand, yes, and then
All right. Thanks, Richard Tribou, Orlando Sentinel. This question is for Steve. How deep into the summer can this mission push without running up on the other ISS traffic? And what is the timeline for certification after landing? And just confirming that SpaceX and Boeing would both be training toward a potential February 2025 launch, depending. That's it. Thank you.
Yeah, relative to the International Space Station and the traffic, as we've talked about, we sort of set up this summer, May, June, July, to really have that window open at the space station. So the next big set of events at Space Station really has to do with our crewed handover coming up, and that's in mid-August, right? We'll have Crew 8 to Crew 9 in mid-August. The second part of the question was relative to certification. We'll have to work with Mark after the flight. You know, we had it laid out when we were in early May. You know, it's a number of months. We're trying to get to a certification review toward the end of the year, and then we'll just have to look at the data that comes out of the flight. We know, Mark talked about it really well yesterday, a number of products that we have to have lined up, and we know what those are. We've started reviewing those, and NASA's approved many of those already. We're also setting up for having the ability to dock at the forward port on the International Space Station, also the Zenith port. So that software is in work, and all the analysis with the space station programs in work. So we have all that underway, and then we are protecting in the February timeframe next year both Starliner 1 and the SpaceX flight as well at the same time.
Okay, go ahead.
Hi, thank you. Marissa Parra with NBC News here. This is sort of a follow-up to Tom's question regarding the timeline. Say you get out there, you make the judgment call that this can be fixed, you make the judgment call later tonight, you're going to work through the night, I'm assuming, to do exactly that. Say you were working through the night, through the morning even, when would be the deadline you say, we simply cannot continue working on this because we're getting too close to the launch? Is it all the way up until launch time, or is it earlier than that?
It's earlier than that because, you know, the rack we're talking about is adjacent to the rocket in that shelter I described earlier, which means that when we begin loading the propellants into Centaur and the LOX into Atlas, that we can't have people there. Because of safety concerns. And so it's at that point that if we don't think we can get it done before then we would not be able to finish.
Okay, and Will back here.
Thanks. Hi, Will Robinson Smith with Spaceflight Now. Thanks again for taking the time to speak with us this afternoon. Question for Mark. Besides the issue with the fans that came up later on in the count, was there anything else out of character with Starliner, or can you talk about how it performed during the countdown process today, and if you learned anything about getting to this point in the count? Thanks.
No, the vehicle performed exceptionally well. We had no other issues that we worked throughout the count. So we'll review data over the next 24 hours to make sure that everything performed as we saw it, but there was nothing there.
All right. Final call out for questions here in the room or on the phone.
I think Mark had a response to my question.
I only care about what my customer thinks, and you heard what my customer had to say. So
I'll pipe in. The nation needs two ways to get to space, at least. We're at the finish line. Let's take one more step.
Tom.
Understanding that this stuff happens, how much does it cost? This kind of assuming it's a 24-hour delay, how much does this cost, and who picks up the cost? In other words, you've got all of your technicians, your engineers, your whoever is on working and has to work again, and the fuel costs. I'm just wondering if there's a cost estimate for that.
I think we'll have to get back with you on that. To be a rough estimate that we would make on how much it costs for a 24-hour turnaround.
All right, Ken.
Ken Kramer, Spaceflight Now for Tory. I think you mentioned, if I understood you right, you can't do RAN steering on here, or you might have a wider launch window. So I was just curious why you can't do that, please. Thanks.
Yeah, so two reasons, and they're both kind of the same answer. It's about energy. For those of you who are not familiar with ascension of the ascending node steering, apologies for the rocket science term, it means that you're able to launch before or after the perfect time. And there's always a perfect time because it's a rendezvous. The pad is moving at 900 miles per hour. You're all moving at 900 miles per hour right now. And the space station's going more like 17,500. And so it's an intercept. And so when those orbital planes go up, that's the ideal time, and it takes the least amount of energy to do that. Because we're flying the trajectory we are, uniquely associated with crew safety, something, by the way, we've never done before the prior Starliner missions. It's suborbital. We're used to going to orbit. But this allows us to fly low and flat with a lot more thrust. That's why there's 2 RL-10 engines on the upper stage instead of 1, so that we've never had a what NASA would refer to as a blackout period where it would not be safe to separate, God forbid, in an abort and have the crew safely return to the Earth. And in fact, when we get done, we haven't given the Starliner enough energy to get all the way into orbit and go to the space station. It then lifts itself. So between the amount of energy it takes us to do that and the energy limits that are on the Starliner to be able to be dropped off somewhere to do that, we're not able to do RAN steering, where we would launch either before or after the ideal time, because that also takes energy as well as some sophisticated guidance algorithms. So this is like everybody else who goes to the space station. We're used to having that 25, 30, 35-minute launch window when we take cargo, because we don't have to do that for cargo. But we don't have that luxury here, and it's about safety.
It's really about the ascent aborts, right? We NASA wanted a very robust abort system should something happen to the rocket. And so, what Tory talked about is the trajectory has been optimized, how the Atlas flies, so that at any point, if the Atlas has a problem, Starliner can separate, fire its engines, whether it be the launch abort engines or the OMAX, separate, and then not pull too many Gs and have a safe entry and land in the water, and we'll go recover them. So it really is about crew safety, as Tory said.
Hey, everyone. Thank you for your questions. We really appreciate your interest in this mission. Before we wrap up, we do want to go over the launch attempts on the 5th and 6th, if you want to do that.
Yeah, I will provide the 2 different launch times for June 5th and June 6th, should we get into those. Of course, June 5th is 10:52 Eastern. And again, the rendezvous is about a 24-hour rendezvous, so you rendezvous approximately 24 hours later on June 6th. And then the June 6th launch time is 10:29 a.m. Eastern. Again, rendezvousing about 24 hours later on June 7th. So thank you very much.
And for those interested in the launch broadcast, we always start around 4 hours before launch so we can capture the crew going in for suit up. All right, again, thank you so much again for your questions. And as you heard our folks here on the dais say, we should know a little bit more in a few hours, 3 or 4 hours or so. So we hope you keep in touch with us and check out our updates on our blog. So we'll pull that up now for you. It's on the screen, blogs.nasa.gov/Boeing Crew Flight Test. We have a lot of blogs. I almost read the wrong one, but it's that one on the screen, blogs.nasa.gov/Boeing Crew Flight Test. Again, stay tuned, please, and thank you for your interest, and have a great afternoon.
It's a new era of pioneers, star sailors, thinkers, and adventurers. 3, 2, 1, 0.